Hello, everyone. Thank you for coming to this talk. The title, as you can see, is 7 Reasons Why Your Microservices Should Use Event Sourcing and CQRS. So I'm kind of looking forward to this talk because if you aren't familiar with Event Sourcing and CQRS, I think you'll have a reasonable understanding of it after the talk. At least that's my intention. But for those of you that are familiar with it, it's often kind of a contentious topic. I've had some really animated discussions with a lot of people, which is always fun. So I've always kind of enjoyed getting people excited about this in either a good way or a bad way. It depends on where people are coming from. So my name is Hugh McKee. I work at Lightbend. For those of you that are not familiar with Lightbend, Lightbend is a company behind a number of different frameworks in the tool set. One framework is the Play framework. It's a web framework, for building the back end to the web front ends. It has APIs in Java and Scala. We have another framework called Logom, which is a microservice framework. It's kind of for people that are new to microservices, so it's kind of a framework that has some guide rails, like patterns for people that are kind of just getting into microservices. And again, it's available in Java and Scala. And my favorite is we're the company behind Akka, which is the actor system on the JVM. And of course, we're also the company behind the Scala language. But all the frameworks and tool sets we provide both have a Java API and a Scala API. But in any case, got a lot of material to cover, so I want to really get going. So a lot of talks about microservices. You always talk about going from monoliths to microservices. But really, it's basically going from one large and complex system, say maybe based primarily on monoliths, to another large and complex system, maybe perhaps is based on microservices. But there are, the motivation for going to microservices, things like being able to move faster, get things into production, new features, fixes, whatever, into production more quickly. And there's other reasons as well, as we'll see as we go through this. But I'm going to be focusing particularly on more of the persistence side of microservices. So I kind of use these industrial complex as a kind of a picture. And I thought this one really represented a lot of what I want to talk about, in that often when people are looking at microservices, there's 2 dimensions to look at it. One is on the processing side or the code side. So a lot of times people are going into microservices and they're breaking apart their code. They're modularizing their code in some form of microservice. Very often, though, I see less people looking at the persistence side, and this is the actual storing of data. And again, with Event Sourcing and CQRS, we're talking about persistence. So we're kind of talking about this whole breaking apart of, say, bigger, more coarsely grained systems into finer grained systems. But it's not just at the code level, it's at the data level as well. And when you start to get into the data level, code is one thing, trying to get, say, if I come from a long time in an enterprise, slow-moving enterprises, trying to get people, the enterprise to adopt new technologies is difficult. So if you're in an enterprise space, my apologies, I guess, but it's introducing these kinds of changes are difficult. But we're talking about kind of ripping things apart, pulling things apart deliberately into a kind of a finer grain kind of a system. And again, it's not just the code, it's the data as well. So just real quick, I like when I talk to people about microservices, I usually try and, in the course of the conversation, understand where you're at, just to give me an idea. So there's like 3 characteristics that I'm trying to look for when, and these are characteristics, these are not rules or anything. You don't have to do these things, but it's kind of like these are good goals to try and achieve. The easy one typically is if you're doing microservices, you have code that's independently deployable. That's one of the major motivations to go into microservice environment, because you want to be able to change something and get it quickly into production without having to, say, change a big, say, monolith. Now you're changing maybe, more finer grained modular components that are, wrapped up in microservices. The fun starts, though, when you start talking about the data. I ask, well, does the microservice own its own schema? And the point here is that, is the microservice responsible for its own data? Or is the microservice using a monolithic database underneath? Very often, see microservices using a monolithic database underneath. There's no problem with that. You're moving in the right direction, but what I want to try and show you is that there are advantages to moving towards a more fine-grained persistence layer as well. And then finally, it's that you really black box the microservice, that the only way to get to the data in the microservice is through its APIs. There's no like backdooring straight into your database. So it's like if you and I are working on a microservice team, our microservice from the perspective of everybody else on all the other teams is that it's a black box. The only way you see our microservice is that you're seeing it through our API. And this is the whole thing with command query responsibility segregation. It's the segregation of the data that we'll see within the microservice. We're taking even a level more. We're not only splitting the data between microservices, but with the command query responsibility segregation, you can kind of think of it as write-read segregation. We're segregating the ways we do persistence inside the microservice itself, inside that black box. But often this is where the fun is, when you have these conversations with people, and this has happened to me a lot, they look at me like I'm crazy, that, that you're opening up this crack that's just going to kill us all, right? And that's not the reality. There's more and more people that are doing this, but it is scary because it is quite different. But I want to try and remove some of that, hopefully remove some of that fear. So I picked the number 7. It was just kind of off the top of my head. There's lots of reasons why. I see advantages for using event sourcing in CQRS, but I thought I picked 7, and then I struggled with, okay, what would I put into that list of 7? So we're going to walk through the 7, but before we get into that, for those of you that aren't familiar with event sourcing in CQRS, I want to just kind of quickly review that because this is relatively new to a lot of people. But it is fairly straightforward in that this is a diagram that kind of represents the basic topology of what we're talking about. That you have say we have a client who's interacting with a service. A request comes in from the client, say to make some kind of a change. You want to change the state of some data somewhere in the service, like add an item to an order, for example. Well, that's handled in the service as a command. And a command is a request to do something that hasn't happened yet. It's a future tense type of phrasing. Please add an item to my order, or please remove this item from my order, things like that, future tense. So the right side processing is one of validation. Is this a command that I can do? Are there business constraints on it? Are there data violations, things like that? But if the command is good, what happens then is an event is emitted. And an event is a historical fact. It's something that's happened in the past, because as soon as an event is created, it's time-stamped. We did this operation at this time, boom. And it's the events that get persisted in the right side. And this is where things get interesting, because with the events going into what's called the event store, the event log, I kind of flow back and forth between event store and event log when I get talking about this stuff. But basically, you have a very simple data structure, which is kind of a key value pair, where the key is, say, the entity ID, the timestamp or a sequence number, and maybe the action. Add item, update item, remove item, add shipping address, add billing address. But what you're doing in this event store is that you're not updating, say, the state of the records that represent the current state of an order. What you're capturing is a sequence of events that was used to build up an order, including things like you added an item, that's an event that goes into the event store. You remove the item, that's an event that goes in the event store. So you can kind of think of it as like an accounting journal. In an accounting journal, you never erase anything, that you're always just inserting, you're always making changes. So if you want to change something in your order, then, or in the order, it's just a compensating action. You added an item, no, I don't want that item, you remove it. So we've recorded each one of those events. The aggregate of all these events give you the current state of the order. Okay, that's what goes into the event store. So this is where your feet start getting hot. The lava is boiling up in some cases, and it's like, oh, what are we talking about here? But it's different. But it's the reason is this is very fast, very simple, very straightforward. You're just slamming events in there, and all you're doing is inserting. No updates, no deletes, just insert, insert, insert. So you have a history of all the events that were used to build up the current state of whatever entity you're dealing with. And then finally, these events then are propagated, and we'll look at the strategies for doing that from the write side to the read side. Now, the cool thing here is that you're free to store the data in the read side in whatever way is optimal for the queries that this service is supposed to provide. So it could be that some of the queries are best served by a relational database, or maybe they're best served by Elasticsearch, or maybe they're best served by a graph database, or maybe you need a combination of multiple databases. Now we have the option to do that, because what I'll hopefully show you over the course of this talk is that there is ways to guarantee that every single event that's captured in the event store, eventually it will make it into from the write side to the read side. Guaranteed that we won't miss any data. Now, the same thing is, say a client just wants to retrieve data, so the request comes in. This is a non-state changing kind of a request. Goes into the read side, performs some kind of a query, which is best served from the query side, because the event store is not very queryable. You might have a primary key and maybe a key on the entity, or an index on the entity, and that's it. Whereas on the query side, it's fully optimized for queries, which might also mean that it's not, it's obsessively normalized. It's maybe more denormalized data, but there's a lot of freedom in how you're actually storing the data on the read side. So that's kind of it. There's the write side. It's just capturing events, very fast, very simple, inserts only. And then there's the read side, which is optimized for queries. And then there's the whole processing flow that goes around it. So now let's get into the reasons. So the first reason that I wanted to kind of discuss is that there's a nice transition from the design phase into the implementation phase, especially for those of you that are doing things like domain-driven design, and this newer one that's come along that kind of complements domain-driven design, event storming. So what this is that with domain-driven design, the idea is that you're trying to identify. To me, it's like I'm a developer, so what I want to know is what microservices does this system, is it composed of? So I look at a domain-driven design exercise. The outcome of that is identifying the microservices. When you're using event storming, what event storming is that you get everybody together for a day or two or whatever it takes, but usually it's a relatively short period of time, and you have the business people in there, you have the development team, you have managers, you have product owners, whoever knows about this particular area of the business, they all get together, but all they think about are events. What's flowing through the system. And they're basically creating sticky notes and putting it up on the wall somewhere. And they kind of gravitate towards each other, where you start to see clusters of events. These are events that are related to orders. These are events that are related to customers. And kind of what emerges from this exercise is this kind of coagulation of clustering of messages. But in any case, what I look at it from a development standpoint is that the outcome of this is we have identified the microservices, but we're also thinking about events. The events are really kind of predominant for the whole team, including the business people, which I think flows very, very nicely into event sourcing in CQRS, because event sourcing in CQRS is all about actually formally taking in commands and producing events and persisting them and processing them through the system. So moving on to more meaty stuff here. Reduced service coupling, or microservice coupling. So an underlying theme of this talk is reduction in coupling. The opening talk yesterday was uncoupling. And I was so delighted when I saw the talk yesterday, because it was like, oh, wow, he's putting more meat into this whole uncoupling thing. And this is really important with microservices. You want microservices to be independent from each other as much as possible. And this is an approach to help you do that. So let's take a look at it. Say we have 3 services, and say service 1 needs to retrieve some information from service 2. So, right, what's so difficult, right? The service 1 makes a request to service 2. Service 2 gets whatever information service 1 wants and gives it back in response. So what's the problem there? Well, it could be that what happens when service 2 is down, right? Well, the blast area could be service 1 goes down as well, because if service 1 can't get the data it needs, it can't do its job. So you can have this kind of cascading failure because coupling is relatively tight here. I haven't formalized it as much as in the talk yesterday, but you can see there's some coupling here between these two services. So service 1's down, service 2 is down, maybe service 1 goes down as well. Not good. And we're going to come back to that, but I want to introduce some other concepts first. So say we want to do something more interesting. We want to actually start changing some data, changing some state in the system. So say service 1 is an order service, and service 3 is like a customer credit service. And just walk through a little scenario here where, say service 1, it's taking an event, building up an order, but the really interesting event is submit order. The customer says, all right, I'm ready. This is the order I want. So the submit order event comes in. Service 3, the customer credit service, is interested in those events. And service 3 needs that message from service 1. Service 1 needs to tell service 3 that, hey, we got a new order. You need to check the credit for that order. So service 3 somehow, and we'll get into that, gets this message. And it does a state change because it checks the credit of the customer, and then it either approves the order or rejects it. If the customer has sufficient credit, the order's good to go. If they don't, the order's rejected. Well, guess what? Service 1 needs to know what the outcome of that process is. So we need to get a response back. But the same thing here is that when the response comes back to service 1, we go through a third state change. Now the order goes, say, from a new state to an approved state or to a rejected state. Okay? So we have the 3 state changes here happening distributed. And this is really where it gets really fun because in a monolith, this probably happened as a single transaction. Easy as, we all know how to do that pretty much. If you've been doing any development with databases, piece of cake, right? Here, we're going over the wire, we're going between 2 services, and you need to start asking yourself, what will go wrong? And I really try and emphasize the word will. And people say, well, if this happens or if that happens, like, no, it's gonna happen. It's gonna break. It's gonna break in spectacular ways that you maybe never even conceived of. So try and think of everything that will go wrong and as you're walking through the design and the implementation of your service, constantly challenge yourself. What's going to cause me grief? When I'm supporting this thing in production, what's going to make my life miserable? And fix it. And that's why, another reason why I really like event sourcing in CQRS. So just real quick, what's going to go wrong? The network's going to break. So service 1 somehow can't, if we're just using HTTP REST here, the network goes down, service 1 can't tell service 2 about new orders. So how do you deal with that? You're going to have some way of dealing with that. It gets even more interesting. Maybe messages got to service 3, the customer service, but before it could act on those messages, poof, it goes out. It's gone. So there's some messages that are dropped. Even more interesting, the work got done. Service 3 did the credit check, either rejected or accepted the order. It was trying to tell the order service what the response was. Network broke. Okay? At the worst possible moment, the network broke as we're trying to send these responses back. And the final insult is that, say, it made the whole round trip, the message arrived back on the order service, and the order service dies before it can process those messages. In every step of this journey through this distributed environment, you have to ask yourself, in every failure scenario, how are you going to deal with this? So you're going to see this kind of approach that I'm showing here in this picture a lot for the rest of the talk, where we're pulling data. The idea is that, and this isn't the only approach, but this is one I think is really relatively easy to implement and is very solid, and it's a well-established pattern that's used quite a bit. But it's where it's the producer of messages is not concerned with the consumption of those messages. It's the consumer of those messages that is concerned. So it's not, say I'm the producer and you're the consumer, it's not my responsibility to get the messages to you, it's your responsibility to get the messages from me. And typically that's counterintuitive, but it's often more straightforward to implement and much more reliable. So things like, say, what I'm showing here though is that the write side and the read side. And what I mean is that we're capturing events in the event store, and we need to make sure that every single event that goes into the event store on the right side needs to get into the read side. So one approach that's used is that there's a reader who's pulling events by an offset. It knows where it left off, the last successfully processed event, and is putting those events into the read side. And it's just trying to keep up with the write side. If the read side goes down, the write side doesn't care. It can keep going. And when the read side comes back up, the read side can catch up. Okay? So we're dealing with a lot of potential problems here where a message, we have to get events from the left over to the right, and this pull approach is great. I'm going to show you a push approach in a little bit, but I'm a big fan of this pull approach, as you'll see as we go through the slides. So the same basic pattern applies to between services. That in the case of order is accumulating events, the customer service is pulling those events and processing them. And then we can reverse the picture here that say now we need to get messages back from customer back to order. So the flow is reversed. Now customer is on the left. It says credit approved or credit rejected. These are just events that are getting persisted in its event store. And order is pulling those things from it. So we have this two-way communication, but it's totally asynchronous and is very, very durable to the different types of failure scenarios that we just walked through briefly. We don't have the time to kind of really go into it, but if you think through all the different failure scenarios, this is resilient to to these kind of failure scenarios where eventually messages will get delivered. And this also applies to if you have Kafka or some kind of message bus in between the services. This is a very common way, very popular, very good way to do messaging. But guess what? The Kafka pattern is the consumer is pulling by offset. And they do that for a reason, because it works, and it's durable, and it's resilient. So there is this, you really need to think about it. The easy thing to do in a kind of a happy path mindset is, we'll just do HTTP REST. Everything's fine. Synchronous HTTP REST. What can go wrong? Well, what will go wrong, right? That's what you need to think about. And it has a place, but it's where basically where you can afford to lose some messages, typically. When you have a situation where you can't afford, like the relationship between the customer and the order service, then you need something more reliable. So this fundamentally asynchronous type of pull approach is a very powerful one. I think it's fairly easy to grok. A little maybe counterintuitive when you first see it, but it really works well. And it's used in Kafka. It's used in Logon, for example, internally, and how it handles messaging, things like that. So let's move on to reason 3. Break the read versus write performance bottleneck. And what I mean by that is that, with regular databases, we're always doing the trade-off between write performance and read performance. And you optimize for reads, it comes at the cost of writes. Like you add more indexes, so your reads are good and they're fast, but then the writes get slower. And you kind of have to be very cautious about how many indexes you add, because the more indexes you add, the more, the slower your writes occur. The less indexes you add, the writes are fast, but the read, the queries might be really slow or, just not feasible because they're doing full table scans or something like that. So this is also being kind of addressed by this segregation of writing and reading, the write side and the read side. The write side is extremely fast. Again, all we're doing is inserts, one after the other, event, 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 going into the write side. That's super fast. The read side is also optimized for queries. Again, like I mentioned earlier, things like the data is designed to be there for queries. It's not designed like the traditional normalized database where we're doing the balancing game between writes and reads. It's more of store your data in the most optimal way for the queries that this service needs to provide. And the propagation of the data between those two sides is this pull approach again. So you can have events getting slammed into the event store, and the read side is trying to keep up. But there's a cost here, and the cost is eventual consistency. So the read side is not necessarily always consistent with the write side, and you need to be aware of that. It's a trade-off. that sometimes it works, sometimes it doesn't. Often, though, I think a lot of people go, oh, no, we can't have eventual consistency. It's just not going to work for us. But I would try and say, challenge yourself. Really push it hard before you give up on it, especially when you're new to this, that eventual consistency is initially new, but when you look at some of the strategies that other companies have used to do things that we thought had to be consistent, they've come up with solutions that are eventually consistent that work just fine for them. I'm not saying it's going to work in every case, but I want you to be aware of this, but I also want to caution you to not give up too quickly when you look at this kind of a pattern for implementing microservices. So the next one is elevate the concurrency barrier. So typically, the traffic to your application varies a lot over time. So it can vary during the day. Like the company I worked for, it was a worldwide, so we had kind of double spikes as the sun went around the world. First, we had a double spike in the morning and afternoon in Asia. Then we had a double spike in the morning and afternoon as the sun went over Europe. And then we had a double spike as the sun went over the Americas. And we got a little bit of reprieve as the sun went over the Pacific, because the Pacific is very big and wide. And then it repeated itself when we got back over the other side of the ocean. But we had these spikes, and it varied a lot. But you have spikes during the day, but you have spikes during the week. Maybe your traffic's really heavy on the weekend and relatively light during the week. Or it could be the reverse. It's really light on the weekend and relatively heavy during the week, during the business week. The real fun ones are the seasonal spikes. These are murder. For those of you that have to deal with seasonal spikes, you have, like, say, almost all year when everything's just working great, and there's no problem. And then you get that seasonal spike, and poof, the traffic goes way up, and the database goes, no. We're not going there. And the way I look at it is that there's kind of this cushiony ceiling. It's a bad ceiling. And in my experience, it's usually the database, where we push the database so far, it starts to get mushy, starts to slow down, and you push a little bit further, and it's like hard surface. And that's kind of the performance graph plateauing and then dropping. Because the further you push into that, what I'm trying to show in this red zone, the worse things get, where it's, you're actually degrading in performance. And we've all seen it. I mean, the one fun thing to read about over the holidays, with the holiday spikes, Cyber Monday, Black Friday, and the other one is Singles Day in China. Have you guys seen the volumes in Singles Day in China? It's bigger than anything. It's like this one, I think it's one day in February, everybody in China buys everybody else a gift. And, the online retailers, the traffic goes whoop, right up. And they got to be able to handle that kind of spike. This is, again, why I like this separation. Because that right side can take those spikes. You get a spike, you get a whole bunch of events in. Maybe the read side can't take it that fast. But it's going to eventually, it's struggling, say, to keep up. Maybe it can't keep up, and it's going to fall behind, but eventually it'll get there. So you got that eventual consistency, but you kind of raised that concurrency barrier. I think it's pushed that ceiling much higher up for those of you that are running into like database performance problems. That was a bane of my existence in the systems I worked on. These were like customer-facing systems, and 24/7, and database issues were just drove us crazy. Where you'd see these, like normally, say the response times to a database operation is 3, 4, 5 milliseconds, and at these peak times, all of a sudden things go to heck, and it's like 150 milliseconds. Like, what the world's going on? And then all the alarms go off, and the lights are flashing, and DBAs are running around with their hairs on fire, and they're going, oh yeah, we'll fix this, and nobody ever gets it fixed, and it's just a miserable place to be. So this another reason why I really like this stuff. Continuing on with why I like is the simplifying and harden messaging. And with messaging, it's really interesting, but I think you kind of need to break things down into these three semantics. There's at most once, at least, I misspelled it, at least once, and exactly once. So it's not at last once. Sorry about that. I didn't catch it till now. Go figure. But anyways, exactly once. So it's maybe once. So at most once is maybe once. That what this means is that you're going to drop messages. That is a perfectly acceptable scenario in many different situations. So if it's okay that you're going to drop some messages, no problem. At least once is once or more, meaning that you're going to get the message once at least, but you might get it more than once. And what could happen is that various failure scenarios have caused the message to be delivered, but the deliverer didn't know that it actually got delivered. So the only recourse is to send it again. So this is the most common. If you need to get messages through, this is the easiest to implement. The harder one to implement is exactly once. And I like to kind of call it essentially once. That there's strategies that you can use that say like Kafka had released about a year or so ago, exactly once delivery of messages. But it's exactly once from the perspective of the consumer. It's not exactly once necessarily from the perspective of the producer. So there's ways to do it, but it's more difficult to achieve. So the at least once is a much easier way to implement things. But here's the push approach. If you're the producer, say you and I are working on a microservice, and we decide, all right, we're just going to, we're producing these events, so we're going to push them to the consumer. So we accept a burden of responsibility there. If we have to deliver these messages and we can't drop any, then we're going to have some way of dealing with messages not getting delivered when we tried. So there's some kind of a retry loop. But another big feature of this retry loop is that it has to be resilient to it going, this service going down and coming back up. So if it's in the middle of retrying to or send some messages that haven't been delivered yet, and it goes down, when it comes back up, it needs to pick up where it left off. So to do that, you need to have some form of persistence on the messages that haven't been yet delivered, which to me smells a lot like an event log or a message queue or something that, the queue of those messages that haven't been delivered. Well, that looks a lot like an event log. But this is a common approach. It works. People, have made this work just fine. And it gives you at least once push, which is important. So that the consumer is going to get the message, but it might get the message more than one time. This one scares me a lot. Because it's like, oh yeah, we'll just use Kafka. Kafka will get the message through, no problem. The consumer has no problem. Kafka's got the responsibility to getting everything over the wire. Great. But it's on the producer. It's like the synaptic gap between the producer and Kafka that's terrifying to me. Because it's kind of a two-step process. You do a database transaction. You get that persisted in your database. Your service does that. Then you make the call to Kafka. What's wrong with this? What's gonna break? Well, if anything interrupts that call to Kafka, what are you going to do with that message? If you just get an exception, go, well, okay. Well, then you have it at most once delivery. So you got to harden this up, right? And this is where this whole pull approach is. That again, if you want to make sure a message is at least once delivered from one side to another, you can do the retry push, but you can also have the pull approach where the consumer is pulling. And this works again between services. It doesn't matter what the consumer is doing with that data. It's the consumer's own responsibility. So in one case, it's a relational database. In other cases, it's just another event log that is putting data into. Or this could be Kafka. The point I want to make is that this could be Kafka, that the producer is internally, say in the service, it's not just a simple call to Kafka and you're good. Because if you're doing that, then it's at most once delivery. If you want at least once delivery, you have to have some kind of retry or some kind of pattern that can recover from any errors. And this works very naturally in event sourcing and CQRS because you have the event log and you're just pulling by offset events and you're pushing them into Kafka. If Kafka broke for some reason, maybe the network's down between your service and Kafka or whatever, you're not going to miss any messages. Every single message will make it at least one time, maybe more than once. So we're getting close. Eliminate service coupling. This is my favorite. And actually, last night at dinner, I happened to talk to somebody, one of the speakers here, and he works for a company who's done about 200 or 300 microservices, and he just started explaining what he was doing. He's like, oh my gosh, he's explaining my talk. Basically, they're not quite using event sourcing and CQRS, so on the inside of the black box, they're not doing what I'm talking about, but everything else they are doing. And it's this pattern. So say, this little example here, say we have a customer service, and all these other services, order, shipping, returns, catalog, whenever, to do their work, they need to get some customer information. So, no problem, right? HTTPS get, pull the information, and then customer gets the information and sends back a response. Again, what's going to go wrong here? Well, customer goes down. What happens? Big blast area, right? It could drag down all these services. Customer's down, boom, everybody goes down. Everybody that needs customer goes down. Not good. Not a good place to be, right? Well, here's an approach. You may have guessed what it is. It's just each of these services are consumers of events from customer. They're keeping their own cache of customer information in their own schemas, in their own databases, right? This works because we have the guaranteed message delivery at least once. And every change that customer makes, these other services are going to see eventually, right? The beauty of this is that when customer goes down, these other services go, I don't care. I'm going to keep running. I have my own view of customer, exactly what I need to satisfy the work that I need to do. This is another one where your feet might be getting hot. The lava is bubbling up to the floor, and this guy's nuts kind of reaction. But this one I love because it's like, if you've done production support, I think it changes your DNA, right? Where you just don't want to be in that situation again where you have services go down, everything goes down, and the business is looking at you like you're a jerk. Your managers are looking at you like you're a jerk. When is it going to be fixed? I don't like being there. I like building systems like this where something goes down and everybody else goes, okay, we'll get it back up as quick as we can. But we're still live. We're still running. We're still servicing our customers. That's a great place to be. And that's why I like event sourcing and CQRS for patterns like this. So there's a lot of power in this. And this is exactly what this guy was telling me last night that they're doing on a large scale. And one of the first people I've talked to, this is kind of a new concept that other people have been bringing up in talks, and I know other people are starting to use it, but I'd never seen it on a scale like what this guy was telling me last night, which is very cool. So finally, the last one is graduate from the IT Nursery. This is getting a little off topic, but I think doing something like this enables us to start to pull away from a lot of the governance and process that, especially for those of you that are in enterprise. If you're not in an enterprise and you can, roll your own database and do this and do that, you're lucky. Go to an enterprise space and then where you have to beg for a database, beg for a topic, fill out all kinds of paperwork, wait for approval. It's not fun. There's a big difference between, oh, we need another topic. Okay, done. Versus, oh, we need another topic. Oh, okay, let's take a half hour to fill out the paperwork. Let's wait 3 or 4 days or a week or whatever to get the topic. And it ends up being where you use less topics, or you use less databases. You're less innovative because of all this friction in the process. So can you tell I kind of hate this stuff? But the reason for doing this in the past wasn't to be mean to us. It was to keep us out of trouble. And the idea was there was order in the process. This governance was order, but the ceremony, I think really adds overhead, especially we're in this more nimble world where if you make a mistake, we're now in a world where we're not doing releases every 6 months or 3 months or every month. We're in a world where we're making much smaller incremental changes to finer grained components like microservices. And if we make a change to a microservice, like say we roll out a change to the customer service and it goes down, the system keeps running. because all the other services are compensating for the fact that another service that they have some level of dependencies on is down, and we can roll back, right? Because it's an incremental change. Let's just go back to the previous version. We're back up. Or if we patch it, we fix the problem, and we roll out the fix. Probably really quick. I think that changes the dynamic quite a bit. So in a way, there's this organized chaos that I think that it introduces when you're starting to use approaches like this, where you have highly resilient systems that aren't brittle and can take a hit and just keep running. But the real goal is this increase in velocity. I mean, there's a lot of goals for, say, moving from the coarse-grained modular approach with, say, monoliths to finer-grained modular approaches with microservices. But one of the big ones is moving fast, new features fast, fixes fast, performance improvements fast, whatever. Just getting things done quickly because you've broken it up into much more easily consumed pieces, which I hope will start to introduce into enterprises that have a lot of ceremony, less ceremony, more freedom to move and innovate and move at a more accelerated pace. And while I was doing this presentation, I came across this quote. I thought it was very appropriate. People are very open-minded about new things as long as they're exactly like old ones. And so that's kind of human nature. I read a book not too long ago that it was very interesting. It talked about change over the course of human history. And for most of human history, change was very, very slow. We were born, and the environment that we were born in barely changed until we died. Now we're in this, that was kind of a natural mode for us. Now we're in this period of extreme change, and it's our fault, right? Us, the software people, I think, for the most part. We're introducing all this change, but we have to be kind of somewhat fearless. When we see change, your natural reaction is, oh, well, this is scary. So event sourcing CQRS, oh, no. It's too different, too scary, too radical. But at the very least, I think you should always be pushing as hard as you can push until it hurts maybe, and then back off a little bit. And this is definitely one of those things that initially when you look at it and you start pushing it, it could hurt, right? Because it's new, it's very different, but it's working. It's working for people like the guy I was talking to last night. This was their pattern, basically doing a lot of the things that I talked about here for how they want their microservices to behave and how they're implemented. And it's really for things like this resiliency and better performance and easier to code and so on and so forth. So I think there's a lot of merit to this kind of an approach. So made it in pretty good time. That's pretty much it. Went through the 7 reasons. There's more. I'm sure I could think of more. I'm sure you guys could think of more as well. But I tried to kind of go from design to talking about some coupling to performance. I kind of really hammering on the database performance with reasons 3 and 4. And messaging, really big part on the messaging. Just kind of harden the messaging as much as you can. Always thinking about when things break. Like throw rocks at your design constantly. Somebody in your team should always be challenging. Be the negative guy, right? What about this? What about that? What happens when we do this? What happens when this breaks? Those types of things. Don't be an optimist. Be a realist. I don't want to call it a pessimist. Just be a realist. Things are going to break. What are you going to do? The fun part, I think, is that once you get into that mode, your building systems then can take it. That's where it really gets fun. And when they actually go into production and they're working and they're really, really difficult to break, the system just keeps kind of going. And all of a sudden, maybe your management is going, hey, this is pretty cool. We haven't had an outage in a long time. What's going on? That's where you want to be. That's what drew me to this kind of stuff. I don't like being in those situations where things go down and they break, and my managers and my business people think I'm a jerk, and they got a lot of pressure on me. Another one I forgot to message is one of the worst situations I've been in is where we had some messaging going on, and we had at least once. We didn't want that. We wanted it at most once. We wanted every single message to go through, and we had millions and millions of messages going through just fine. But every once in a while, we drop one. And then the business became aware because customers were complaining. So the customers are complaining. Then the business complained. Then our management is going, have you fixed the losing messages problem yet? And we didn't know what we were going to do. This is some years back, but it's like, it was miserable to be in that kind of situation. And it was one of those things where, again, it was like, I'm vowing I don't ever want to be in this position again. And that's when I saw this and what people are doing, the customers we're working with are doing with this stuff, it's extremely powerful. So I'm not saying, again, that this is the thing that you should use all the time, just like, other talks here, it kind of depends when, should you use microservices or not. It's the same thing with should you use event sourcing in CQRS or not. Is eventual consistency, for example, tolerable or not? You have to do the trade-offs. Nothing comes for free, but it's a cool pattern and something you should really take a serious look at. So thanks a lot. And then any questions? Yes.
In a messaging topic, you've introduced a model when at least once message should arrive. And I'm curious, what is a business situation where we can afford losing a message, basically?
There's, it's like in some cases, say you're feeding data to be analyzed. So say you want to know about the behavior of orders, and it's going to some analysis system. And if we lose some messages there, the analysis system can still kind of derive patterns of order processing with most of the data, high 99.99 whatever number of messages, and some are dropped. But in the case of that's why I was trying to show them that example of these two different services that each are kind of working collaboratively with each other, and the messages, we can't afford to lose any messages. So it's kind of a case-by-case basis where you have to have it, guaranteed delivery. And that's what I like about the semantics. You have to make a decision. Do you care if you lose some? And you look at it straight on and say, all right, we're fine when some messages are dropped. And you make that conscious decision to, yep, messages are dropped, we're cool. But at the same time, you look at it and go, oh, well, what are the odds that this is going to happen? And it's like, okay, you're gambling, right? Because it's like, it probably will never happen. It's like, okay, you're gambling again, right? Where, say that between the order and customer service, the odds of losing a message are fairly low. You're going to get millions and millions of messages through, but every once in a while you're going to drop one. And then you're going to make a customer mad. And then you're going to make the business mad. And then you're going to make your managers mad because you lost one message out of millions, right? That type of scenario. If you don't want to be in that place, then you have to have some kind of at least one scenario. And that's why I like that pull approach. Simple. I've got a source of data that I can easily pull from. I get that message and I do whatever I need to do with it, and I just keep pulling. And I know also as a consumer that I might see the same message more than once, so I have to compensate for that, which it's very specific on the strategies, but you're aware of it, and as you're implementing the solution, maybe you have to filter out. Oh, I already saw this message. No, I just ignore it because I know this is going to happen. So the consumer has that ability to filter out, like dedupe the incoming messages. Does that help? I think the thing though is that every scenario you look at the messaging and go, should it be? Do we have to make sure all the messages get through or not? And the easy one, the thing that scares me is the easy one that people implement is, oh yeah, we just use REST all over the place. REST all over, all the services. That's at least once. I mean, at most once, right? Which means maybe once, which means you're going to drop some messages. And then you look at it and go, okay, we're going to drop some messages. Think about you're in production and you drop some messages. And maybe you drop more than a few messages. And you go, okay, that's not a place that this particular part of the system needs to be. Then you're going to have to look at, all right, we need to implement something that guarantees that we're going to get all the messages. And that's what I was trying to hope to show you here, is that this is one of the reasons why I like event sourcing in CQRS. I got that event log we can pull from. There's relatively easy ways to make sure that every single message gets through in many different implementation approaches. Not easy, I know.
Yeah, and I'm also thinking, what would be my motivation to implement service in a way that it's not 100% reliable, that it's a 99.91% reliable?
Can you ever implement anything that's 100% reliable?
Of course.
An optimist. I like it. I don't know. I think it's...
but sorry, it's not about whether I can or not do it. It's a contract that I'm saying that this service will be delivering messages mostly, and some other service will be delivering messages all the time. And
that's what I was talking about, that with the at least once, you're getting message will be delivered all the time. Now, when they actually arrive is, due to the nature of the current state of the system. You could have network outages. You could have, say you're running in Kubernetes and pods have gone down for a bit and then they come back up. You need to be able to handle those kinds of permutations of the environment so that nothing gets dropped when all these things are,
yeah, but dropping container or pod, it's a kind of crisis situation. It's not a contract. And as far as I understood from your presentation, it's a contract that the service is not super 100% reliable, that are actually counting or maybe even wanting to lose a message.
It's not, it's more of just the reality of the situation is that, like the lifespan of a typical Docker container running in Kubernetes is on the order of hours, right? They don't last forever. They come and go, and they can go at the worst possible moment. That's, I think, the reality of our runtime environment. And that's what pushes us, I think, towards, things like in this talk, the event sourcing in CQRS and strong at least once messaging, things like that, because we just don't have an environment that we can count on. Things are going to break. I mean, one thing that really surprised me when I started to get into distributed systems was how flaky the network is. That at one moment, the network's just fine. Two servers are talking to each other just as happily as could be. And then at the next moment, they can't. And for a few minutes, say, messages can't flow. And then all of a sudden, it's better. And it's like, and I've saw this over and over and over again. And you talk to the network people, nothing, we don't see any problem. But the network was out for like 2 or 3 minutes or a minute or something. Well, it was the nature of the beast. We had to, write services that could live in that kind of environment, deal with those kind of realities. And that, again, why I like this stuff.
Okay, from the opposite point of view, there is a model where it's at least once. Therefore, this model doesn't count with a message losing.
Yeah, but if you have message that's only relevant for a couple of seconds and you're gone for like 20 minutes, then you don't care about the messages that were relevant 20 minutes before. They are not relevant for you anymore, so you don't need them delivered. You lost them, so you lost them. They were relevant 20 minutes ago. They're not relevant now, so you don't need them. You're fine with losing them.
Yeah, but I'm talking about outage in a service where we are expecting at least one message, which we are not receiving when the container is down.
Yeah. But eventually, the idea is, though, eventually the service will come back up and it will catch up. The messages will get delivered. It just because of the fact that a service is down for a while, when it comes back, if you really have to get those messages, it'll get them. That's the whole pull approach, because the consumer, say this service is a consumer, it comes back up, it starts consuming again. So it starts consuming from where it left off, because it knows, this bookkeeping, it's a responsibility of the consumer to know what's the last event that I successfully processed? What's the offset of that last event? So when it comes back up, it goes, oh, okay, the last one was 123, so I need to pull event 124, and just resumes from there. So in the meantime, the producers continue to produce while the consumer is down. But when the consumer comes back up, it starts consuming again from where it left off and eventually catch up. If the data is no longer relevant, I mean, the data is still relevant. In a scenario that your colleague said next to you there, that say over the lifespan of the data is finite, then maybe the data is no longer relevant, so we move on.
So it's not a solution for real-time systems when a consumer should be real-time. It's a solution when you should guarantee that something will happen now or later. Yeah,
because you have that eventual consistency, right? So if the eventual consistency latency is not tolerable, then this isn't a solution. But like I said earlier, push that. Is it really necessary for the whole thing to be real-time? Are there parts that are really real-time and parts that could not necessarily be real-time? Challenge yourself to make sure. There are going to be scenarios where it's not going to fit, for sure. No doubt about it. But push it hard before you give up. That's all I'm trying to say. Any other questions? We're out of time. I'm here all afternoon, so if anybody wants to chat, I'm more than delighted to do it. Thank you very much again.